So today my talk falls around the RDS and its myth. So most of you are familiar with RDS, right? So today we'll see about a little features about the RDS MySQL and Aurora, what it provides and what it does not, and we'll break the myths. What is the selling point of Amazon? Okay, this is little about tech speaker, blogger, and amongst one of the co-founder of Mydbops. Okay, this is the structure of Mydbops. One is support for provider for our client. There is a consulting services as well as the managed services. With consulting and managed service, we have provided a lot of consulting and day-to-day activities for big tech clients who are both in AWS as well as in on-premise. So today this is the agenda of our talk. So why we are moving towards RDS and is MySQL, and what are its features, like the deployments and how it maintains the availability with RDS. And next we'll see about the myths, that how it is become cost effective and what are the myths, how to look for the cost effectiveness and the downtime failures, then the auto tuning with the configurations, then the 5x faster database, that is the Aurora, and the security. Okay. So first, little housekeeping. So as you all know, this RDS is a fully managed database relation service provided by Amazon. So it is built to provide easiness with the setup, operation, and at scale. So it was first deployed in October 2019, that is 10 years from now. It is production for 10 years, and over the 10 years it has evolved a lot. That is, there are a lot of more features being added to RDS every year, as you can see, from them. And in the last release also, there was a new feature, that is the RDS proxy, that is being added as a feature for the RDS. So these are the RDS offerings. As you can see, the Amazon Aurora tops the list, and MySQL, that is a community version, MariaDB, Postgres, Oracle, MySQL, sorry, MySQL server. Okay. So why people are moving towards RDS? So as you have seen, over the last decade, you can see there's a boom in the cloud. All the people, like most of the data and the companies move towards the cloud for the many features like the elasticity, the instant scaling, and these things. Okay, so these are the reasons why people are moving towards the cloud, and it's obvious. Okay. This is one of the important features, that is the cloud or the DC, on which the servers are hosted comes with the complaints. There is a PCA compliance, a HIPAA compliance for the health information data and these things. This is one of the key features that people are moving towards the compliance. The maintaining a compliance on an on-prem system becomes very difficult. You have to manage your all. And recently there was a change in the financial data sector. That is, there was like all the financial data for India has to be maintained within the region. So there was a huge migration of data from other regions like Singapore towards Mumbai. So this is, the compliance is specifically to the regions. For example, North Virginia might have a compliance specific to its own locality. Just read through the compliance of your region and then try to move it. Okay, what are the things you can scale with RDS? So that is the instance, obviously, the scaling and scale up. And next, the rate replicas for providing your read traffic or scaling your read traffic, and the storage. Okay. So this is a simple thing for instance scaling. Okay. So for example, you are running on a 2x large machine, and your production system, the traffic grows, and you want to upscale your system. It's just simple as this. Just go to the console, select your machine, just modify, and just be aware while clicking this apply immediately button. Since when you accept this, the instance starts upsizing immediately, and you might face a downtime. So next is the read replicas. So RDS supports read replicas, both Aurora as well as the MySQL, that is GPL version of MySQL, supports the read replica scaling. So the read replica creation is just online. Just modify, just go to the console, click and create the read replicas. As you see, the community version of the RDS just supports 5 read replicas, that is asynchronously. When you need to go for more other rate replicas, you have to create your own snapshot and configure the replicas external. Next comes RDS Aurora. So this is a completely owned engine by Amazon. So it's a compatible version of MySQL. They have heavily patched the underlying architecture of Aurora to make the scale. And they support 15 rate replicas concurrently. This is a disk-based cluster. I would say Aurora disk is a cluster. And the cross-region replica is also supported with RDS. So this is just a snap from the console how you have to create a rate replica. So next, the scale part comes to the storage. So recently, the RDS released a feature that is almost within a 6-month back. That is an auto scaling feature with the storage. Previously, with the previous versions of when prior to that, you have to set a disk size. For example, if you are going with a 500 GB disk, there will be a fixed disk size, and it cannot grow. It needs a manual intervention. You have to go to when the disk got filled, you have to go to the console and increase the disk manually. This is now cleared with auto scaling. Previously, the auto scaling was available with Aurora. With Aurora, when the disk grows, it automatically extends with a 10 GB of extents. And higher the disk size, the next comes the better trade-off, that is disk IOPS versus the disk storage. So disk storage and disk IOPS are proportionate. For example, when you have IOPS is in the ratio of 1 GB is equal to 3 IOPS. The higher the disk, that is in terms of storage, you get a better IOPS. And when you go for provisioned IOPS, it is a paid version of IOPS. As you can see, 1000 IOPS is built at a rate of $100 per month, which is pretty huge costly. And the max cap limit of the IOPS in the standard SSD is 16,000, and with the provisioned IOPS, you can provision it 80K IOPS. And with Aurora, as I said, disk is a cluster. And with Aurora, the data is being replicated among the 3 availability zones within a region and maintains a 6 copies, so there is no failure of disk, even if there is a failure of the instance. Okay. So now let's see how Aurora and RDS MySQL provides high availability. So every production system needs high availability. When a master goes down, the next instance or the slave has to take over the role of the primary and continue serve your production traffic. So what is the lead time or the acceptable time for the slave promotion? So that is the main thing that it has to maintain from the application end. So RDS provides 2 ways of high availability with RDS MySQL as well as Aurora, that is ACs. So that is multi-AC. So when you go for a multi-AC concept, it's like a primary instance and a standby instance. So the standby instance will be in a different availability zone as a background instance or a standby instance. It will be replicated synchronously with a concept called DRB. There is a disk replicated block device in the underlying technology. This instance as a standby, right? You cannot use this instance for a rate replica or a rate traffic. Only when there is a failover or there is a crash of instance in the primary availability zone, the secondary instance comes into the picture that takes the role of the primary. This AC switch or the server switch is maintained by an internal DNS. So when the primary goes down or crashes, the DNS propagates or makes the changes, and your endpoint remains the same, and standby becomes a primary, and you can continue the traffic. And as with Aurora, as you can see, this is a shared distributed storage work. That is the disk is shared among the 3 availability zones. The disk extends among the availability zones. For example, when a master or the primary goes down, one of the rate replicas, that is a 15 rate replicas, get promoted to the master. So this is the architecture of the Aurora cluster. Okay. Now let's break them in. So the key selling points of Amazon, right? So they say when you are in an on-premise system, your cost of operation goes more, and when you go to a cloud provider or AWS, they say that the cost of operation gets down, or it's cut down by 50% or 100% cost saving or 80% cost saving. So this is not true with RDS as well as Aurora. Okay, This is a simple graph or the map. So nothing comes free. That is for sure. What are the things we are using? For example, the operation cost, the ease of operation comes with the cost. This is a normal EC2 instance. So hope you are aware of the EC2 instance. It is an infrastructure as a service where you get a box, you deploy your own MySQL on the EC2 and just start running. So this is we have just made a small cost comparison in the Mumbai region for an 8 CPU machine with 64 GB RAM and 500 disk. So the cost of the EC2 machine is around 434, and when you the same instance, it's not an AC, it's a single standalone instance. When you go for a RDS MySQL, it comes around $854, which is almost 2x costlier than the current EC2 machine. And when you go for Aurora, it is further more. That is, it is $1,424. Even with Aurora, you can see a hidden cost of the storage also whenever the storage extends will be built. So please choose your instance or the way of moving towards the RDS based on your need. So cost versus the feature price. So how much you are going to pay for a feature? For example, whether it's a multi-AC. Again, when you go for a multi-AC, the standby instance is also built, which is 2x from your current bill. And the passive instance, as I said, it's a DRPD application. I do not use it for any purpose. And the only purpose that the standby instance serves is a backup. When you run a backup on a single node versus a multi-AC enabled node, the backup will from the multi-AC node, and you'll have a better performance on the master. So next comes the myth on the disk. Okay, so disk is the cheapest, as you know, from the RDS, but it can also be costlier when you use the provision IOPS. For example, this is the normal disk from the last slide I have seen, right? The 500 GB hard disk. With the rate of 1 GB is equal to 3 IOPS, it provides the normal disk provision with 500 GB provides 1500 default IOPS. When you go for a sustained IOPS, when you need more IOPS for operation, you go for the provision IOPS. When you go for the same provision IOPS of 1500, you have to pay extra $160. That is almost the double. That's more than the double. So, and when you go for a 500 GB, the same 500 GB hard disk and for a 300 IOPS, it is $257. So the cost of the provision IOPS, right, it keeps on dumping when you go for a higher provision IOPS. So this is very costly. So this is some guidelines for the effective usage of the disk with RDS. Okay, so you connect your performance and features. If your app is able to get a retainable threshold, that is, you are okay with the DNS failover, all these things, you can go for the multi-AC concept. And when you have a growth versus the disk size versus the provision IOPS. Okay. So when you have more IOPS, when your production system is in need of more IOPS, you can just extend the disk. Don't go for provision IOPS. That can save much as well as providing the growth of data. Next, plan for your capacity. Okay. It's not like the Amazon says that you can scale your instance in minutes. Yes, obviously, yes, you can scale the instance, but it comes with a great cost. When you plan for a capacity planning with the reserved instance prior to the on-demand instance, the rate completely varies. That is, with the reserved instance, you can get around 50 to 60% of the cost saving. So next, what Amazon claims is a zero downtime failure. Okay. There is no zero downtime failure, as I said, even with enabled with multi-AC or with the Aurora clusters. So what it takes for a failover? When an instance crashes or instance goes down, your existing connections, for example, you might be using an application that connects your endpoint to the primary. When the crashes or when there is a failover, your existing connection gets lost. Or when the connection comes back, there will be a log in the application log, you might see the connection failures. You might need to rebuild the connections. So that is the downtime. Next, it takes around 60 to 120 seconds for the internal DNS change to happen and the endpoint to be available for the application use. So there should be a retry mechanism or application retry mechanism from the app side. Okay, so this is a failure mechanism, how it happens. See, as I said, it takes usually 60 to 120 seconds, and also it is based on the transaction. For example, if your database is highly concurrent, highly transaction, if it crashes in the middle, then it has to run its crash recovery from 3 to 1, then the time increases. This time it takes extended. To avoid this situation, to avoid this failover time, better plan for the parallel environment. When you have a planned cutover or a planned maintenance where you are moving for 5 minutes, make a parallel environment with a slave, then cut over it, and then it should be easier. Or you can use proxies like proxysql or an output to the endpoint to parallelly transmit the traffic flow to the other instance and then cut over it. Proxies in the sense we have a lot of proxies. For example, maxscale is one of the SQL other proxies, and we have one more proxy, it's a proxysql. It's a balancer that sits in between the application and the team. It routes the application traffic. Yes. So next comes the important bit, that is autonomy. Okay. So when you start an instance or when you create an instance, the instance will come with some configuration. For example, MySQL will be a default. The same with the RDS or the Aurora. When it comes, when you start an instance or create an instance, then you can see the parameter rules and the default parameter rules and the default option group that will be set to that instance. Now see what it is. Okay. So Aurora or the RDS MySQL by default it tunes only the two variables by default. That is only buffer full size. By default it set is 2, set to 75%. That is this is the formula that they use to calculate the instance based on the instance size and also max connection. So this is very generic. Whatever the instance type you provision, whatever the type of the instance you provision, these are the two formulas that is applicable and the instance comes with that. So when you go for a customized options, you have to create your own parameter group, own option group, and make your settings accordingly. And then one important thing is that when you go with the Aurora or the RDS, all the data in the logs goes to a single disk. That is, you have a more of an IO head or a single disk. When you go for example, when you have an EC2 instance, for example, you have an EC2 instance, you can provision a separate disk for data and a sequential disk like a hard disk for the log directory, and that saves your IOPS and the pressure on the data. Okay, this is a comparison chart. So I would like to stress more on this. So as the MySQL version grows from 5.6, 5.7, 8.0, so you have more controlling variables. As you can see with 5.6, you have a controlling variable of 487 variables. You can control, you can fine-tune or fine-grain your MySQL production on an on-prem or EC2 instance. With 8.0, you have 783, which is the highest. When you move towards the RDS or the Aurora, the number keeps decreasing. As you can see, with RDS, the configurable variable, that is the variables which can be tuned, is given as 327, out of which the configuration you can change is just 282. That is 61 or almost those variables are not configurable. That is a static variable. And even when you go to Aurora, you can see the 5.7. You can see the graph comparison between 783 and 580. They just expose only the 519 variables. Out of the 519 variables, you can tune only 361 variables. And when it goes to Aurora, it is further more down. And you cannot configure much of your variable. That is, you are losing control of your MySQL or your production system. And you are more getting addicted towards the RDS. So, next comes the Aurora. What Amazon claims is that with Aurora, they claim it is a 5x performant, okay, than a normal MySQL. That is a community MySQL. Okay. But what Amazon doesn't say is that is it a read-centric or a write-centric workload. Okay. Of course, yes, for the read-centric workload, Amazon Aurora scales very well. And we have seen that customer getting benefit out of the read traffic. When you go for a write traffic, when your production instance is very much write intensive and you need more of a write, the Aurora fails it. You have a commit latency. This is because the redo log sizing, right? The redo log sizing is not configurable with Aurora. So that is the reason. So it is a storage cluster. So the transmission, that is, it has to maintain a core within the cluster. So the data has to be propagated across the ACs. So the propagation, when you increase the size of the redo log, the propagation takes later and the cluster obviously fails. That is the reason. When you go for an Aurora cluster and you search for a variable, InnoDB log file says those variables will not be visible at all in the parameter code. Okay. This is one of the big performance bottleneck with Aurora. And also we have helped a lot of customers who are in Aurora, even from Amazon Aurora RDS to normal RDS or a normal distribution. Next comes the security. So you all say that this data centers are compliance, whatever things. So we move our data to the Amazon cloud, we are completely secure. It's not true. Okay. So it's a shared responsibility model. As you can see, the customer also has some responsibility in maintaining the data. That is, with the RDS, the underlying host infrastructure or your software, that is MySQL, is maintained by the Amazon itself, but the access to the data, the incoming request, that has to be maintained from the client end. So, but how you maintain that? With the VPC configurations, by securing your database instance inside a private VPC based on your need of an application. Then you configure the security groups to maintain the ingress, that is the inbound and outbound rules. Then you secure your data, the incoming data and the outgoing data on the network or on the wire through SSL. Right? So I think I have covered all the myths. So there are a lot of myths to be covered, but in the interest of time, I am stopping it here. So we have also discovered some of the bugs. For example, with RDS MariaDB, we had mentioned a bug which is 2 years back. That is a replica doesn't start. And also, when you go for a RDS or Amazon MySQL, you are completely dependent on the Amazon for their patch releases. Okay. Amazon might not cope with the patch release of Oracle. For example, I can see the latest version of 8.0 is 8.0.16 in RDS MySQL, but whereas in Oracle it is 8.0.18. So they heavily patch or they hide the variables underlying, then they release their patch version. So this makes the security bug fixes delayed with the Amazon. Thank you. Any questions?